Okay, today we're going to look at Spearman's rank coefficient of correlation. And I've got a question here that you can see straight away. Now what this is a pie eating competition. There are 9 pies. Judge 1 has scored it these scores, and Judge 2 has given the pies these scores. Okay, Judge 1 has obviously given the pies a better score than Judge 2, but what we want to test to see is whether the Judge 1 and Judge 2 are in numerical agreement. Now you could plot this on a correlation graph, and we could see whether or not the crosses form a negative correlation or no correlation or perfect correlation. But what we have to understand is if there's a perfect negative correlation, it is assigned a numerical value of -1. No correlation is 0, and perfect correlation is 1. Now, what that tells us is that correlation ranges from -1 to 1. Now, anything between -1 and 0 has some negative correlation, and anything between 0 and 1 has some positive correlation. The closer it is to 1, the stronger the correlation is. So anything over 0.8 is extreme, there's really strong correlation, and anything close to -0.8 is strong negative correlation. Anything below that is classed as there is some correlation, but it could be weak. Okay, so the closer you are to 1 or -1, the better it is. Now there is a numerical formula for this, which is called Spearman's rank correlation, and it's given by this formula. Now the formula looks very tasty, but actually isn't that bad. It is 1 subtract 6 times the sum of d squared divided by n bracket n squared take 1. Now d is the difference in the rank, and n is the number of items that you've got, number of pairs. Okay, now we're going to apply that to our 2 judges with the pies. So we're going to rank these judges now from lowest to highest for both judges. Now you can go highest to lowest, but you have to be the same for each judge. So rank 1 for Judge 1, this was the lowest score. So 1, then we've got 13, then we have 18, then we have 19, then we have 20, then we have 23, then we have 24, then we have 27, and then we have 29. So 9's our highest value, so this is, Judge 1 said it's the best pie, and he said H is the worst pie. Now let's rank the next set of judges. Lowest to highest again. Then it's 4. Then we have 7. Then we have 8. Then we have here, we have 5. And this one is 6. And then we have 17, 8, and 9. Now you can see the ranks are pretty close, so they do seem to be fairly well in sync with each other. So what we have to do now is take these ranks away. So 3 take 3 is 0, 7 take 8 is -1, 6 take 5 is 1, 2 take 2 is 0, 8 take 7 is 1, 4 take 4 is 0, 0, 0, -1. Now the same with the mean with standard deviation. We need to square these in order to remove the variation. Okay, otherwise if we add these up we will get 0. So 0, 1, 1, 0, 1, 0, 0, 0, 1. Now the formula is 1 minus 6 times the sum of these squareds divided by n squared take 1. So 1 subtract 6 times the sum of these squareds, now 1, 2, 3, 4, divided by n, which is, there's 9 sets of values, so it's 9 times 9 squared take 1. So this is 1 minus 24 times 9 times 81, take away the 1 is 80. So this gives you 1 minus 24 over 720. Now if we type this into our calculator, I'll just get my calculator, and 24 divided by 720 is 1 minus 0.033, and then if we do 1 minus 0.033, we get a correlation value of 0.967. So the judges are pretty much in agreement, 97% in agreement, so they're highly correlated. Okay, so that's how we decide whether the judges are in agreement in this case. Now I've got a separate question here, which is a drama exam, where the two components have been given 2 scores. Now again, we're going to rank these to see if there's an agreement between the two compositions that are the best students ranked at the same and the weakest students ranked the same as well. So let's start with this. So we've got the lowest score here is 56, then we have 62, then we have 70, and then we have 275. So that's rank position 4 and rank position 5, which are tied. And if that's the case, you split the rank. So rank 4 and rank 5 would become rank 4.5 for each one. And then we've got 90, which is rank 6, because there are 6 pairs. Now we've got the next one here now, which is the weakest, which is 1. Then we have 64, which is 2. And then we have rank 3 and rank 4 are tied together there. So 3.5 there and 3.5 there, because rank 3 and rank 4 is halfway split. And then we have 86, which is rank 4. And then we have this one, which is rank 5, apologies, because of the split. And then we have rank 6. So now we look at the differences. And we have 0, we have 1, we have 0, 3 take 3.5 is minus 0.5, 4.5 take 5 is minus 0.5 again, and then a 0 on the end. So d squared would be 0, 1, 0, 0.25, 0.25, and 0. So the sum of d squareds would be 1 plus this, which is 1.5. So let's apply the formula. 1 minus 6 times the sum of d squareds. N over n squared take 1. So we have 1 minus 6 times 1.5 over 6 times 6 squared take 1. So we have 1 minus 6 times 1.5 is 9. 6 times 35, which equals 1 minus 9 over 210. So it's 9 divided by 210 gives us a value of 1 minus 0.043. So 1 minus 0.043 gives us a correlation of 0.957. So we've got a 95.7% correlation. So it's a really strong positive correlation between both pieces. Thank you.